Hello everyone. So in today's class of COA of BCA third semester, we shall study flip-flops. So I guess you might be knowing the meaning of flip-flop. So what is the meaning of flip-flop? I tell you. So flip-flop is nothing but it comes under sequential circuit. Okay. So while discussing about half adder and full adder, we discussed about how digital logic circuit is divided into two types. One is combinational digital logic circuit, another one is sequential digital logic circuit. Okay. So what is the meaning of combinational? Combinational means the output of the circuit depends only on the present status of the input. That is called as a combinational. Now, what is sequential? Sequential means here the output of the logic circuit does not depend only on the present status of the input but also on the previous status of the input. Okay. So, the example for the combinational we studied two circuits. One is half adder, another one is full adder. So, that comes under combinational. Whereas sequential circuit best example is flip-flop, counters. Okay. So, what is this flip-flop actually? Flip-flop is a digital logic circuit which is nothing but sequential circuit, and one flip-flop can store only one bit at a time. Means either 0 or 1. The capacity of one flip-flop is nothing but 1 bit. Okay. And we usually call as storage element. Why do we call it as a storage element? Because whenever we need to store the data, usually we store it in the memory. Generally we call it as memory. Then what is this memory? Memory is nothing but it is made up of resistors. What are these resistors? Resistor is nothing but a group of flip-flops. For example, if we call it as 4-bit resistor, what does it mean? That means that resistor is containing 4 flip-flops. Okay, so resistor in which we are going to store the data. That's why flip-flops are called as storage elements. Okay, so this is about brief introduction about flip-flop. Flip-flop is a digital logic sequential circuit which can store only one bit at a time, and that's why it is called as storage element. Okay, so in the flip-flop we have to study 4 flip-flops actually. Okay, the first one. The first one is D flip-flop. Okay, here D stands for delay. Okay, so we can call it as a graphical symbol of D flip-flop. What happens in the D flip-flop? See, and this one is, see, this is the symbol, graphical symbol. So here we are having two inputs. One is D input, another one is clock input. What is this clock input actually? Clock is nothing but it is considered as a reference signal. Okay, so the clock appears like this. Means, see here we are having two outputs, Q and Q bar. So as the symbol indicates, Q bar is nothing but a complement of Q. Okay, so here the clock is considered as a reference. The reference is nothing but on which state of the clock the output has to change. Okay, for example, D input is 0 0 1 0. What will be the output? That is Q. Q will be 0 0 1 0. So here the output is same as that of the input. Only thing is it is delayed. Then how it is delayed? That I tell you. Now see, this is our D input and this is output, that is Q. See here, this is the pulse and the value of the pulse is 0 here, 1, 0, 1, 0, 1. Okay, so what is here? See, this whole value is 0. Okay, the whole value is 0 and here it is 1 and here it is 0 and again here it is 1. Okay, see, what is the input? If you consider only 4 bits, 0 1 0 1 is the input. What is the output? 0 1 0 1. Then what is the change? The value remains the same, only thing is it is delayed. For example, if this 0 takes 1 second to travel, if this 0 takes 1 second to complete its cycle, then obviously this takes double, that is 2 seconds. So here this value has taken 1 second, the same value here it is taken 2 seconds. What does it mean? The value is same, only thing is it is delayed. So why we use D flip-flop? We use D flip-flop when we need the output same as that of the input. This is one reason, and one more reason is when we want the output to be delayed. Okay, that time we use this D flip-flop. Okay, and what is this clock? Clock is a reference signal that indicates you when the output has to change, during which state it has to change. For example, here, if you think that, okay, so negative edge of the clock cycle. Okay, so this is negative and this is positive. Okay, if the indication is like during the negative edge of the clock cycle the output has to change, means during the negative edge this has changed. It is like a clock which we use in our daily life, that is clock. For example, the class duration from 10 to 11, if that is the duration, we are having one boundary. Okay, so we are supposed to take class from 10 to 11, not before 10, not after 11. Okay, so that is how the time plays in our daily routine, in our daily life. Similarly, in the flip-flops, this clock plays the role of clock. Okay, so this is about D flip-flop. And one more thing is truth table. So it is very simple. Input is nothing but D and output is nothing but QI. When input is 0, what is output? Same 0. When input is 1, output same 1. Okay. Next, we can take one reference as a clock. Okay. So here, this indication, there are so many symbols for the clock. For example, when the output has to change, whether during the positive edge or during negative edge or at the edge. So there are 3 types. Okay, the symbol of this one is positive edge. Therefore, that is indicated like this. So this is the truth table of the D flip-flop. Okay, next we shall study T flip-flop. So about T flip-flop. T flip-flop, T stands for toggle. Sometimes it stands for trigger. Both are not the same. So as the name indicates, what happens here? Exactly reverse of T flip-flop. Okay. So the graphical symbol. So this is only change. Instead of D, here we are having T. Okay. So the truth table of this I tell you. Okay. So here what happens I tell you. When the input is 0, the output doesn't change. What does it mean? If previously it is 0, if the output, that is Q. If previously it is 0, when output becomes 0, it remains the same. If the output is 0, okay, when input becomes 1, it changes. Changes means it becomes 1. Okay, so that means what? Here, when the input is 0, the output remains same. It may be either 0 or it may be 1. When the input becomes 1, then the output changes automatically. So that is the meaning of what? T. That is the thing but toggle or trigger. Means it changes. Initially if it is 0, output is 0 and the input becomes 0, then output remains constant. When it is 0, if our input changes to 1, then output suddenly changes. That is the meaning. Next, we shall study SR flip-flop. So this is the graphic symbol of SR flip-flop. See here, this is bit different from D and T. See, in case of D and T, we are having single input. If it is D, only D, T, only T. In this case, we are having two inputs, S and R, along with clock. Clock is everywhere, in every flip-flop. So, S stands for set, R stands for reset. So, this is the graphical symbol, and if you observe the truth table, see, as we are having two inputs, we must have 2-bit combination input. So 0, 0, 0, 1, 1, 0, 1, 1. Okay. So when it is 0, 0, the output will be 0. When SR is 0, 1, output is 1. And when the input is 1, 0, the output is QI. QI means the input. Means there is no change. Whatever is there, that remains same when the input is 1, 0. When the input becomes 1, 1, it is unpredictable. So unpredictable means we cannot decide what will be the output. That's why it is called as unpredictable, and this state is a disadvantage. This stage or this concept of this SR flip-flop is nothing but disadvantage, because in the truth table we must have the output value for every combination of input value. But whereas here, for the 4 input combinations, we have output only for the 3 input combinations. For the 4th one, we don't have the output. I mean, we cannot decide the output. That's why this is called as a disadvantage of SR flip-flop. Okay. So to overcome this disadvantage of SR flip-flop, there is one more flip-flop called as a JK flip-flop. See, JK and SR, there is no much difference between these two. The only difference, as I told you, to overcome the disadvantage of the SR flip-flop, JK flip-flop has been made. So what is that disadvantage? This one. So in case of SR, this state is unpredictable, whereas in case of JK, it is QI bar. What does it mean? That means the input will be complemented. If it is 0, it becomes 1. If it is 1, it becomes 0. So this is about JK flip-flop. And this is clock as usual. Okay. So this is about flip-flops. So for your syllabus, you have only 4 flip-flops. So now we shall study the last concept of this chapter, that is state table and state diagram. So what is this actually? See, both the concepts are related to flip-flop circuits. Okay. So state table is nothing but this one, nothing but a truth table. Okay. So what is mentioned in the truth table? So it is nothing but the behavior of the flip-flop, which is described in the form of truth table, which is nothing but called as state table. So what is a state table? How to define it? State table is nothing but the behavior of the flip-flop is described in the form of a table, nothing but a state table. Then what is this state diagram? The state diagram I will draw now. So state diagram is nothing but the behavior of the flip-flop is described in the form of a diagram called as state diagram. Now the question is, what we are supposed to do? See, when state table is given, we must be able to draw the state diagram. When state diagram is given, we must be able to write the state table. Okay. Now, what is this? This is nothing but a state table. Now I tell you how to draw the state diagram when a state table is given. Okay. See here, what is there in the table? Present state, next state, input and output. These 4 are compulsory concepts which are appearing in the truth table or state table. Now, what we have to do? See, first we have to look at the present state. What is present state? 0, 0. This is how we are supposed to draw the present state. Okay. What is next state for this? See. When present state is 0, 0, what is the next state? That is also 0, 0. It means here itself. For this present state, we have the next state as the state itself. Okay. Now, what is input? X. What is output? Y, that is 0. Input is also 0, output is also 0. So here we have to write input 0 bar output 0. This is how this row is represented here. Okay. Now coming to the next one. Input state is 0, 0, means we have to consider the same state. Then the next state is 0, 1. Okay. So when input state is 0, 0, the next state is 0, 1 with arrow mark. What does it mean? It means when input state is 0, 0 and the output state is 0, 1, 0, 1. For what input and output? Input is 1, output is 0. So input is 1, output is 0. So this is very simple to draw. Now the next one. When input state is 0 1 means we have to come here now. Okay. Output state is 0 0 means from here to here we have to move now. Okay. That means we can move like this also. When input is state is 0 1, the output state is 0 0. Input 0, output 1 means input 0, output 1. Now next one. Input 0 1. Input state 0 1 here itself. Output is 1 1. From here to here you can move. 1 1 with this arrow mark. What is input here? Input is 1 and output is 0. So input is 1, output is 0. Very simple. Next, 1 0 input means we have to come here. Okay, somewhere. Okay, 1 0 is not there. 1 0 input and output is 0 0 means it is related here. Let us make the input state 1 0 here and 1 0 to 0 0 with input 0, output 1. 0 input, 1 output. Next, when input is 1 0, this one, okay, output is 1 0 means the state itself. So here comes here like this. When input state is 1 0, the output state is also 1 0 itself, and the input is 1 and the output is 0. Input is 1 and output is 0. Okay. Now the next one, 1 1 means we have to come here. When input is 1, when input state is 1 1, output state becomes 0 0 means from here to here. What is input? 0, output 1. So 0 1. Next, input state is 1 1. This one. Output state is 1 0 means here. Input 1, output 0. 1 0. So this is how we need to draw the state diagram, which is very simple one, because in the question itself there is an answer. Because we know input state, we know output state, we know what is input, we know what is output. So depending on this, we just need to draw it neatly. That's it. Okay. Vice versa. Vice versa means what? When we have the state diagram, can we be able to write the truth table or state table? Yes, of course. See. See, you started from 0 0. Input state 0 0. Okay. Then output state 0 0. What is input? 0. What is output? 0. Input 0. Output 0. Okay. Next. Again one more is there. 0 0 0 1. 0 0 0 1. Input 1, output 0. Input 1, output 0. Okay. Next. Coming to this 0 1. 0 1 to where? 0 0. Input 0, output 1. So this is how we can draw, we can write the state table when we have state diagram. So this is very easy concept, very simple it is. When we have state table, we have to draw the state diagram. When we have the state diagram, we should be able to write the state table. So this is the concept of state table and state diagram. I hope you understood. Okay. If you have any doubt, of course, we will be there to repeat it. Okay. So try to understand this. Okay. So by this we completed first chapter of COA. So in the next class we will begin with second chapter. Okay. Till then, go through all the videos of COA first chapter, study it properly. If you have any doubt, of course, we will clear those doubts. Okay. Till then, take care. See you.